So we have 72% of all Americans live in cities with population greater than 100,000 people. If 45 Americans are randomly selected, find the probability that. And the question was on part C and D. So let's look at those two questions. So at least 30 of them live in cities with populations greater than 1,000. Okay, so let's think about what we have. All right, we have 72% live in the city. So they either live in the city or they don't. So this sounds like a binomial distribution or a binomial probability we're going to be looking at. So my n is our sample, so that looks like 45. So that's going to be my n, and we'll need to know that. And at least 30. So let me think about that for a minute. How would I write at least 30? So we know our n is 45. If I can write here. There we go. And we want the probability of at least, so X is the number of Americans who live in the cities, that would be greater than 30, greater than or equal to 30, right? So 30 or more live in the cities with populations greater than 1,000. All right. So using our calculator, we can calculate this. We're given our probability right here. So my P is 0.72. Now our calculator, when we use it, and I'm going to bring it over here, we will go to second vars, and that will bring up a distributions, and I want my binomial. And I'm going to use the CDF, cumulative, since it's an inequality. It's not an equal, exactly 30. So we're looking for accumulation. However, this looks for everything less thans. It doesn't look for greater thans. So if I put in, for example, let me just go ahead and bring it up. The number of trials goes first, so it's 45. The probability will go next, 0.72. And then now we need to figure out, if I put in 30, that's going to give me the probability that X is less than 30. And that's not what I'm looking for. I want it to be 30 or more. So I really want to look for the complement of this. So let me get that. So I'm going to use my calculator to find the probability that it's less than 30. I'm going to put equal to there. So less than 30, I'm going to actually put in 29. Okay, since we're talking about people, we're going to go down 1. So let me get my calculator back up here. All right, so I'm going to put in 29. So that's going to give me everybody 29 or less. Okay, so I'll hit enter. So the probability that, they're less than 29, or 29 or less. Now the complement of that would be 30 or more, which is what I want. So I'm going to do 1 minus this answer. Okay, so I went second answer. That way I don't have to type it in. And hit equals, and it looks like it is 0.8328 if I round to 4 decimal places. So depending on what you're asked to round to. So it looks like for this one, okay, it's 0.8328. Let's see if I can write it in here. Maybe 8328. All right. So let me clear this off. I still need the probability, and my n is 45, so I'll leave that there. All right, now the next one is asking between 28 and 35, including 28 and 35. So I want the probability that, and again, we're including 28 and 35. Okay. And we want to know the probability that the people that live in cities fall between this amount. So let's think about what we have here. All right, so let's say here's 35. and here's 28. So I'm looking for the people in between. Now again, using my calculator, if I use my binomial, let's clear this. Let's go back to second vars, find my binomial, CDF, enter. The 45 hasn't changed. It's still 45 Americans selected. That's my sample. The probability is still 0.72. Now, if I put in 35, and it says including, so I would want to use 35 there. That's going to give me everything less, all the way to 0. Okay, all the way to 0, which is part of what I want. However, I don't want everything after 38. Let me move my out of the way, and let me get a different color pen here. So again, when I put in that, it's going to give me everything till I get to 0. Okay, I don't want all of that. I just want this part right here. I just want this. So what I need to do, okay, I'm going to find that probability, okay, the probability that we just found here. So let me go ahead and enter it. And I get 0.8489. So again, let me move that out of the way. So this whole probability is 0.8489. But I need to subtract out, okay, so anything less than 28, we're going to look at that and subtract it out, or subtract it from this 8489, okay, and that'll leave us with what we're looking for, the area in here. So bring my calculator back, and I'm going to go back to my vars, or my distributions. Go back to my binomial, CDF. There's the number of trials, comma, the probability, comma. Now I want 28 to be in the part I'm looking for. So I'm going to go one less to 27, because I'm going to subtract 27 and less out. I don't want to subtract the 28. And enter, and I get 0.0553. So let me go back here and select my pen. And so this yellow part right here is 0.0553. So I want to do 0.8489. Subtract out this part right here. 0. Which we just found. 5.3, and it looks like I have 6.39, 0.7936 for the probability that we have between 28 and 35 Americans living in cities with populations greater than 100,000.